kind of talk a little bit about programming in general. Let's go ahead and get started with our talk. So before talking about Python, I do want to talk a little bit about programming as a whole. If you haven't worked with programming in the past, you could think of programming as a list of instructions that the computer can execute for you. And each of these instructions is called a statement. And I like to think of it like you and I can be speaking in English, we understand each other. You could turn to someone else and talk to them in Spanish, they might understand you. When you're talking to a computer, you need to learn a language that the computer understands. Because if you don't speak the same language as the computer is not really going to know what it is that you want it to do. So one of the languages out there is Python. And some of the reasons why you might consider using Python are, well, the first one is that it's beginner friendly. So you might start seeing in the examples that we go through today that the syntax or the grammar used in Python is very human readable. So when you start looking at the logic in Python, you're going to see, like in the example I have at the bottom, that it uses English words to kind of outline what it is that the computer is going to do. So in this example, we have a statement where we want to print the statement hello world, and the command in Python is print. And in other languages, you might see that they're not as clean or just saying the English word print. So that's one of the reasons why you might consider starting with Python. Another reason is that it's very versatile. So if you're interested in doing a multitude of things in computer science, Python is very user-friendly for that. If you're interested in data science, now everyone talks about artificial intelligence. If you're interested in doing those things, Python is very useful in building tools, using toolkits that other people have built out, or if you're thinking of automating some tasks on your computer, Python's also useful for that, or even web development. Again, there's many different languages you could use, but Python is one of the languages that you could use for web development as well. So here's some of the reasons why Python. And some of the things that we're going to talk about today start by touching on the main building blocks of Python. So we're going to talk about variables and data types. Then we're going to talk about how a computer program makes a decision. This is essentially done by implementing conditional statements. Then we'll talk about how you can perform repetitive tasks using Python and also organizing some of your code. And we'll finish up by touching on some advanced tools or some of the additional toolkits you can use, known as libraries, to expand the capability of Python outside of just the bare bones initial Python. So starting off, looking at variables and data types. So a variable is a container that can store specific value or data. I like to think of this the same way that we have variables in algebra, where we might set x equal to 2, y equal to 5. When you set the values of those variables, then you know that when you have x plus y, you know the actual answer is 5. Why? Because you set a variable value to those variables x and y. Very similarly, in Python, you can create variables with a variable name of your choosing. You follow it with an assignment operator, which is an equal sign, and then you tell it what value you want to store in that variable. So variables pretty much allow you to store values that you're going to be using throughout your code. And then when you start working with variables, I use the example of algebra, where you can set numerical values to the variables that you're using. When you start working with Python, you're going to see that there's multiple data types. So in math, we typically only really work with numbers. But when you start working with Python, you're going to see that your variables can hold a multitude of things in them. Here, I've highlighted some of the more common data types. One of them is integers, so whole numbers. You can store a whole number as an integer in a variable. You could also store floats. So this is essentially a decimal point number, so numbers with decimal points. You can see here pi equals 3.14. This is a float stored inside of a variable. We can also go beyond just storing numbers and store text. Text in Python is known as a string. So when you have a variable that doesn't hold a number, you're going to hear that being called as a string data type. Here we have a variable named university, and we're setting this equal to the string value UCR. And lastly, you can also have a collection of items stored within a variable known as a list. So let's imagine you want to have a variable that stores all the classes that you're enrolled in. So you create a variable named classes, and you have a list with 3 items in it: art, math, and English. And don't worry so much about the syntax or like the rules of coding at the moment. Right now, I kind of just want you to familiarize yourself with like the different components of the language so that when you start programming, you can kind of go back to documentation and additional information and say, oh, I know what a data type is. Let me see what data types are available for me. So another thing I want to introduce you all to before I go to the coding notebook is a comment. So a computer pretty much executes the instructions of code that you give it, but there are times that you might want to write something in your code that you want the computer to ignore. How do you do that? You do that by starting your line with a pound sign or the hashtag. And like we see here, if we start with the pound sign, this tells the computer whatever comes after this line is a comment. And you might ask yourself, why do I want a comment in my code? 2 big reasons are to document or explain your code. And another one is if you're testing something out and then you don't want to test it out anymore, but you don't want to delete it, you could just put a comment. But the more important one I would say is documenting or explaining your code, because I'm sure most of us have worked on something that takes, I don't know, a week, a month, and we might work with it for multiple days and everything makes sense. I know exactly what it is that I'm working with, but then you pause for a month and then you come back to work on it again, and you might be thinking, well, what was I doing? I don't remember everything I did a month ago. So then a comment allows you to write little instructions for yourself or your collaborators to know exactly what it is that your code is expected to do. So let's go ahead and look at an example on Google Colab, the Hello World example. If you haven't programmed in the past, Hello World is kind of the introductory example for all coders to kind of get started with how things work. So let me see here. First thing I want to show real quick, well, this is the notebook that we're going to be using today just to walk through some examples. But if afterwards you want to start your own Google Colab notebook, if you have a Gmail account or a Google Drive account, the way to start a new file for you is very similar to starting a Google Doc file. You're going to go to New. And then you're going to see More down here. And then in More, you're going to see a file type named Google Colaboratory. So I'll make it a little bit larger. And I like to think of Google Colab the same way that I compare Word and Google Docs. If you haven't used Google Colab in the past, but you have used Google Docs, you might have seen that to use Word, you have to download an installer, you have to install Word on your computer, you might have to pay for it. And then with Google Docs, you just have to have a Google account, you log in, you don't set up anything, and within your browser, you can get writing. So very similarly, Google Colab allows you to start coding without setting anything up on your computer. Everything's stored on Google Drive. So I know earlier there was the comment about local work. So this is pretty much done on the cloud. But one of the strong benefits of it, especially when you're starting to code, maybe you're testing out examples online, is you don't have to worry so much about the dependencies or the code set of, you can just get like started to practicing stuff. So yeah, so with not seeing it, it would be that you start a new file, More, connect more apps, and then you would be able to search for it here. Let me see. So Colaboratory. So for me, it's already set up. You would just have to install it. 2 things I want to point out with Google Colab is that you have a document known as a notebook made up of cells. And then the cells can be made up of one of 2 types. And if I hover here, you might be able to see, yeah. One type is a code cell, and the other type is a text cell. So a text cell is just like here, allows me to write in plain English. You can add titles, subtitles, body, that's all in the text cell. And then the code cell, gonna look a little more colorful. That's kind of like preset by the notebook. But the main difference you're gonna see, other than the font looking a little bit different, is that there's gonna be a play button on the left-hand side of the cell. So what that play button's gonna do when we click it, it's gonna allow us to execute the code inside of this code cell. So Before I started talking about Colab, I mentioned we would look through a hello world example. So that's what we have here. We have a cell that starts with a comment. The comment pretty much just tells us, oh, we're gonna have a hello world example underneath. And that's just for us to know, followed by the statement print, the line hello world. And the way that this is set up, that's Python syntax. For a print statement, you would essentially write print, open close parenthesis, and then whatever you want to print out, you would enter inside of that statement. So when we run this cell by hitting the play button, we're gonna give it a little bit of time to work. We're gonna see two things. The first one is that there's a green check mark on the left that tells us our cell executed properly the way that we expected. And the second is that we successfully printed out the message, hello world. So we printed out the message on the screen. The green check mark tells us it's good to go. And now let's look at variables. So let's say here we printed out something in like just string. We just wrote out exactly what we wanted to print. But what if we wanted to print out the value inside of a variable? Let's say we created this variable named text and we assigned this value inside of the variable. If we want to print that out, I would just hit the play button to see that naming the variable inside of our print statement allows us to print that out. And in this small example, you might be thinking, well, I could just write out like the text instead of using the variable. But when you start programming and projects start getting larger, you might see instances where variables are more helpful. Like what if you want to print it out 5 times? You could just use the variable like to print, well, 4 times actually. To print it out 4 times, you could just do this here. And let's say you wanted to change the message. Rather than having to change the message 4 times, you just change it once and it like changes it throughout all your outputs. Let's see. Another quick example I have here of variables. Let's say we want to design a little application that helps us calculate our average GPA for a term. So we want to ask ourselves, what grades do I need to get if I want to have an average GPA of 3.5 or above for this term? So I can estimate that I could get a B or 3.0 in math, an A in English, and a B in Spanish. Will these grades get me through to get to my goal of 3.5? So the first thing I need to do is set the values of the GPAs to specific variables that I'm creating. I'll run this. And the reason I pointed out the green check mark before is because all this cell is doing is assigning values to the variables. We don't really have an output, but the green check mark tells us we successfully ran this cell. We successfully assigned values to the variable. That green check mark tells us we stored it. And then when we run this cell down here, where we are calculating the average GPA and storing it in a variable, we can print out the GPA and we can see, oh, well, with this GPA 3.3, it's not quite at our goal of 3.5. Well, what if I get a 3.7 in math instead? So I rerun it to restore it. I rerun it again. Okay, this quick application let us know that if I get a A- in math, an A in English, and then a B in Spanish, we can get a 3.5 target GPA. So some of the use cases of variables at a small scale here, building a small application. Now we talked about variables, data types, a little bit about comments. Now let's talk about making decisions in your code with conditional statements. So everything we saw so far was, let's go through every line in our code, execute every single instruction, unless it's a comment or the pound sign. What if we only want to execute specific lines of code if specific conditions are met? So conditionals allow our code to run blocks of instructions only if certain conditions that we set are met. I kind of put these little icons at the bottom, like you might be playing a video game and you're only really able to play if your health bar is over 0. Once your health bar reaches 0, game over. That's a conditional statement there. Or you might be shopping online and you might see if you spend over $50, you get free shipping. So if you go to your cart when it's under $50, you might see you're still being charged for shipping. But conditional statements allow that shipping to drop when you meet the condition. Similarly, like our thermostats at home, we set it to, 71. If the temperature is over 71 degrees, turn on the AC to get going. So essentially, conditional statements allow our code to only run when whatever conditions we set are met. The three main keywords in Python to get going with conditional statements are if, elif, which is short for else if, and else. So if is if this condition that I set is true, do this, whatever it is you want it to do. Else if the first condition wasn't true, then do this other thing instead. And then else, I have it kind of here as a catch-all. If none of the conditions I set at the top are true, then do this other thing. And we'll go through an example together to kind of give you a sense of how you can set up your conditional statements. So kind of going along that example of calculating your grades or figuring out what grades you have, let's imagine you want to convert your percentage grade to a letter grade. You're trying to determine, do I have an A? Like, first, I just want to know, do I have an A in the class? So the conditional statement is your grade greater than or equal to 90%? If it is, then yes, you have an A. The way that this looks in code is, if grade is greater than or equal to 90, print A. But if you look here, only one thing is really checked. And you're going to see once we go to the notebook what happens when you don't have like something over 90%. Like this only takes care of that specific condition. With computers, you have to be very specific on what it is that you want them to do. So if you don't tell them to handle or do anything in the cases where this is not true, it's not actually going to do anything. So let's say you actually want to look at two conditions. Is my grade greater than 90% or not? So here you kind of have a little binary like decision tree. Is it greater than or equal to 90%? Yes. Then you have an A. No, not an A. So what we saw back here, you only had one conditional statement for one check. Here, we could have two kind of like checks to print out the two outcomes. So we print, if the grade is greater than or equal to 90, print A. Else, otherwise, if this isn't met, print not an A. And the third kind of setup with the if, elif, else is incorporating elif itself or else if. What if we want to know the specific letter grade that we have from 0 to 100, or even if there's extra credit, like 105 or something? The first thing you check is your grade greater than or equal to 90%? If it is, then you know you have an A. If it's not, you check the next thing. What about 80%? If it is, then it's a B. If it's not, you go to the next check, and so on and so forth, until you get to this bottom check. Is it greater than or equal to 60%? If it is, you know it's a D. Otherwise, stop checking. We know that if none of these conditions were met, then we know we have an F. So that's where if, elif, and else come in handy. So even though there's only three sort of like keywords, you could kind of make checks for multiple different states, not just the three. So let's go ahead and quickly look at this example on the notebook. So the first thing I'm going to do is I'm going to create a variable named grade. And inside of this variable, I'm going to store the value 85. That's the grade that I want to check where it falls in the A through F letter grade scale. We run it, we see the green check. The green check tells us we've successfully stored 85 instead of the grade variable. And the first thing we're going to do is check if the grade is greater than or equal to 90, print out grade is an A. And based on kind of what we saw in the slides, knowing that grade is equal to 85, when we run this check, does anyone have a guess of what the output's going to be once we print it out?
It will not print anything.
It will not print anything? Correct. So when we run it, the condition's not met, nothing's printed out, this is skipped. The only thing we're printing out is this that's like outside of the conditional statement. We're checking if the grade's an 8, 85%. We didn't tell our computer what to do when the condition's not met, so it went ahead and skipped it. But over here, we can handle for that by incorporating the else statement that does something when this condition is not met. And when we run it, you can see checking if grade is an A or not an A. When the grade's an 85%, the grade is not an A. And then the last one, which we looked at on the slide, was if we want to know exactly which letter grade we had, then we go through all these checks. We run it, and we see that the letter grade is a B. And I want to spend a couple minutes on this specific setup of if, elif, and else, just to point out a few things. So the first one is, whatever it is that you want your code to do if a condition is met, needs to follow this first conditional line, followed by an indentation. This indentation is what essentially tells your code, this is what I want you to execute when my condition is met. So right now we've only been printing out letter grade is B. But what if we want to print out like the same thing, I don't know, 5 times? Like, let's imagine it's different things that you want to do. This indentation tells us that all of this is part of this single elif statement. So when we run this, we see that it's printed out 5 times. So with conditional statements, you're not like tied down to like a single instruction. You could have multiple things happen as long as that indentation rule is met. And then the other thing is to notice how technically 85 is greater than 80, 70, 60, but we only really see one output. And the reason for that is that with conditional statements, the only set of instructions that we execute are the first ones that we see that are met. So since this one wasn't met, we check the second one. And since the second one was met, then our program knows, okay, then we can skip everything like under it until we get to like the end of our little if, elif, else group of conditional statements. So along with that, you need to keep in mind that order matters. Since only the first condition that is met is the one that's executed, the order in which you outline your conditions is gonna impact the output. Because let's say that the first thing you check is if your grade is greater than a 60, then you have a D. When you run this, you're gonna see that the program's incorrectly gonna tell you that even though your grade is an 85, you have a letter grade of a D. Again, computers are very much like, tell us exactly what it is that you want us to do. Like they have no context, or at least like in these examples, like they have no context of what letter grades are or what the order is. So this specific block of code didn't really reach this elif statement because this one kind of triggered it, like this grade over 60 is true, we're skipping everything else. The third point I wanted to touch on was repeating specific parts of code or organizing your code. The way that you do this is by incorporating loops and functions into your code. So loops allow our program to perform repetitive tasks efficiently. So rather than you having to write and copy paste the same thing over and over again, you could use loops to do that for you. So there's 2 main types of loops. The first one's called a for loop, and the second one's a while loop. So looking at the for loop first, the logic behind a for loop is for every item in a group of interest, do a specific task. So a for loop is very useful when you know how many times you need to loop through a specific list of items. You know you have to do a specific thing 10 times, you could use a loop for that. If you know you have a list of 15 items and you want to do something to each of those items, you could run through that as well using a for loop. And a while loop is more useful when you don't necessarily know how many times you're going to be looping or performing an action. So the logic behind this is, while a specific condition is true, keep doing something until the condition is no longer true. So I'll go through a couple examples to kind of show like some real use cases of the for loops and the while loops. So the for loop could be, let's imagine you want to write a program that renames 50 files, or you just have 50 files on your computer. The traditional or like the manual way to do it would probably be to right click on the file, go to rename, change the name, go to the next file, right click, rename, change the name. But if you're using loops, you could write a program that tells you, go to this folder, And for every file in this folder, I want you to perform a specific action. So the program's gonna know I have to look through every item on this list. And once it reaches the end, it's gonna stop. The while loop, one example I like to think of is when our computer might be trying to reconnect to Wi-Fi. So I don't know if like when you are in Gmail or Discord or something, you might get like not connected to the internet, trying again in 5 seconds, not connected, trying again in 10 seconds. So without a loop, you would probably have to sit there and click retry a bunch of times because you have to manually like try to connect. But when you're using a while loop, or like in this case, the service provider has like a while loop running in the back, it's pretty much saying, while there's no internet connection, try to find a connection again. If we don't have it, check again and try again, until we have a connection, then we know we have to stop searching for an internet connection. So the key difference here is that the while loop stops running when the condition or the state changes. So let's look at these in Colab real quick. So we want to point out like, so I mentioned the examples of changing the file names and connecting to Wi-Fi. I have some code here to kind of simulate that. We're not actually changing the file names. I didn't want to do that, just to keep the example a little bit concise and look more at the process of how the loops work. But the way that I set up this example is we have a list, and this list has 3 elements stored in it. These are 3 files that we want to change the names for. And the way that we do this, rather than having to change the name for each one, we write a loop for, that's the keyword to start a for loop, for file, and this file is a loop variable. For file in files, files being this list up here, rename our file by adding copy underscore at the beginning of each one. So the way that you would do this, you run it, and you could see that with 1 line of code and a for loop, we were able to execute like 3 rename actions. And then for this second example, where I'm simulating kind of trying to connect to the internet, first thing our program is going to print, I'm searching for a signal, and then it's going to run while not connected to the internet, print not connected, and trying again in 3 seconds. This is kind of the simulation part. All I'm really doing here is randomly selecting a value between true and false. And when true is randomly selected, then our program's gonna like kind of step out. So don't worry too much about how like the simulation set up. The biggest thing you're gonna see here is that this while loop is gonna run until this connection is no longer disconnected. Yeah, so the not kind of throws it off. While not connected, keep running. Once you see that it's connected, step out of this and print out the message that's not indented, print connected. So we're gonna run this. The first time we run this, we see that it tries to connect once, 2 times, 3 times, a couple more times maybe. Yeah, so it had to try 5 times because we didn't know when it was gonna find a connection. This was just a random choice for the simulation. If we run it again, we might see that it might not take 5 times to connect. It might take, yeah, so in this instance, it took 3 times. So in that case, a while loop just runs the number of times it needs to run until this condition changes. Very different to the for loop up here, which no matter how many times I run it, it's always going to run 3 times unless I change the number of files up here to, let's say, see if that works. Yeah, let's say I want to rename 9 files instead. Then it did change, but I knew exactly how many new files there were going to be, and every time I run it, it sticks to 9. But the while loop just runs until the condition. The last part of code I want to talk about is functions. So a function is a reusable block of code that you can use to perform a specific task. So the good thing with functions is that you can define code one time and you can use it multiple times throughout your code. So you're going to see that there's an input that you will You could give it any input to the function that you predefine when you define your function. Then you go into the function to perform a specific task, and then it gives you an output or the result of running whatever you define in the function. For this specific part, I kind of set up an example of a temperature converter. We want to set up a little function that we could run multiple times to calculate different temperatures from Celsius to Fahrenheit. So we know that the formula is Fahrenheit equals Celsius times 1.8 plus 32. Can we write a function that allows us to calculate this out multiple times without having to write out the formula every single time? So for this, we have this function here. And for this one, let me actually start a new code cell. The keyword to define a function is def. So def tells our, pretty much tells our interface, whatever we write after def is going to be a function definition. So I don't necessarily want you to execute what's in the function. I'm telling you what you want to execute every time I run the name that I decide. So in this case, I want to set the name equal to Celsius to Fahrenheit. And then the next thing you do is after the function name, you put a open and close parenthesis and a colon. Inside of the parentheses, you would put anything you want to pass in as an input for a function. In this case, we want to pass in Celsius. So I'm creating a variable for the function named Celsius. Then whatever comes under the definition of the function name is going to be the function content that's going to be executed when I run the name. So the three things I want to do are the three things I want to do. First, I want to grab this input Celsius, multiply it by 1.8, add 32, and then store the output inside of a Fahrenheit variable. Then I want to print out what the Celsius value was and what the Fahrenheit value was. So I'm going to run this block of this code cell, and we're going to see a green check mark tells us we successfully ran this cell. And in this case, running the cell means that we successfully created our function. Nothing was calculated. The only thing that took place in this function definition stage was creating what's going to happen every time I use this name. And we're going to see down here, to use a function, you're going to have the name followed by whatever input you want to give it. So let's say first we want to convert Celsius to Fahrenheit with a value of 0. We run this, and this line of code went back to this predefined function and said, okay, well, what I need to do is first calculate Fahrenheit and then print out Celsius and Fahrenheit. So when we have 0 degrees Celsius, it's 32 degrees Fahrenheit. When we have 25 degrees Celsius, it's 77 Fahrenheit. And then 100 Celsius, 212 Fahrenheit. And again, this was a small example, but this kind of shows you how functions can be very useful, because if you're going to write a program where you might need to do a specific thing multiple times throughout your code, rather than copy and pasting your code over and over again, you could just define a function. And this is specifically useful because if you need to change something in this with a function, you only have to change it once. Like here, if I had calculated these three things and instead I decided I want to put Celsius and Fahrenheit in all caps, I would have to change it 3 times or as many calculations as I did. Or in this instance, I only have to change it once in my function definition. And then when I run these specific cells, I can see that it automatically updates it for us. I want to briefly touch on expanding on Python's capabilities. So there's something called libraries, which are essentially toolkits that other people have already created for you to bring in additional functionality to what you can do in your Python notebook or environment. So libraries are essentially collections of pre-written code. They allow you to import that functionality. And this allows you to solve more complex programs without having to reinvent the wheel and writing everything from scratch. Some built-in libraries with Python are the math, random, date, time, and time libraries. Math allows you to perform some mathematical operations, like if you want to calculate square root, you could do that with the math function. If you want to generate random numbers or make random decisions, you could use the random one. If you want your notebook to have the ability to handle dates and times, like if you want to find out what today's date is and whatnot, the date time library helps for that. And if you want to allow your code to keep track of time for a specific purpose, the time library helps for that. And I don't necessarily have an example for that, but I do want to point it out up here in the example where we kind of like searched for a signal at like this little simulation. I imported two libraries, the random library and the time library. Because like I mentioned earlier, with code, you kind of have to be very explicit in what you want the machine to do. It doesn't have the same understandings that we do. So if you want the computer or the environment to know what a second is, like, hey, I want you to wait for 3 seconds, you have to import the time library so that it knows, okay, let me stop for 3 seconds because I'm defining it here. Similarly with random, if you want to select something randomly, this allows the program, it gives it the additional ability to make a random choice. And then a couple or a few other libraries if you're interested in data science. These are the Pandas library, helps you with data analysis. NumPy helps you to do more advanced mathematical operations. Matplotlib is really useful for data visualization. So if you're creating charts, plots, anything like that, Matplotlib is really useful. And something I like with these libraries versus like a user interface sort of data analysis software, like I've used Power BI and Tableau, and the charts are more customizable at times on those platforms, but you have to create each chart one at a time. You first have to look at this variable and then that variable, and all of that is manual. But with Python, you could essentially set up loops that iterate through your entire table and kind of generates all the charts for you, all like with a few simple commands. And then the last library, if you're interested in learning about machine learning, scikit-learn is a very useful library that kind of has all of that built in for you to train models, work with your data, make predictions, and all that fun stuff. Like I mentioned, these slides are going to be sent out probably in the next week or two. And I've linked here the documentation for all of the libraries I just mentioned. I know when I started to code, I didn't know documentation was a thing. So documentation is essentially, I would call it like the user guide for a library. So you're not really like expected to like know all the syntax and all the rules of coding. If you're using the Pandas library, for example, you could go to their documentation and look at their getting started guides, their user guide. So let's see here, like it tells you how to install Pandas. Maybe this one might be better. Yeah, like it tells you here's some brief examples of how to get started with the library. And I've linked all of these here for you. So not only the documentation, but in some cases also the cheat sheet. So they've put together these documents kind of with the most, I would say, most used functionality within each of the libraries. They don't want to look through the entire user guide. These cheat sheets are helpful as well. I also want to point out some other online resources. W3 Schools has a pretty solid, I would say, intro to Python sort of program. And what I like about it is that it has little examples and problems for you to work through. So W3 Schools is an option. Geeks for Geeks also has intro to Python. And I think they also touch on some of these libraries. So if you're interested in like going into the data science side of things, they have that as well. And as it's probably everywhere now, Gemini, ChatGPT, AI is always a tool as well. I do like want to, like whenever I mention that, like I have definitely like asked Gemini, like, hey, like, can you write this out for me? And one good practice well, a few good practices, like one, I like asking it, can you explain everything line by line? And so that way I can check, okay, that makes sense. No, that doesn't make sense. If you're learning, it might actually walk you through its thought process in a sense. But also I've seen it make a lot of mistakes. So take everything with a grain of salt when you ask Gemini or ChatGPT to build something for you, because with straightforward problems like like maybe the little GPA average calculator I did at the beginning, it might be fine. But if you start building larger applications, it does pay off to familiarize yourself with the documentation, so you can almost like verify whatever output you're getting from AI. But with that said, as I mentioned at the beginning, I'm the data scientist here. So if you have questions about data management, data planning, analyzing or visualizing your data sets, or if you need to publish your data for research, I can also talk to you about that. You can access my services through workshops like today, consultations, and also if you're at UCR, we can also consider collaboration between your research lab and the library. And I mentioned at the beginning that we have multiple workshops. So the two that kind of like follow this, like I guess like the two that I'm delivering regarding Python specifically is going to be data cleaning for machine learning with Python, as well as intro to machine learning. But some of my colleagues here at the library are also giving some great workshops regarding AI. So actually this afternoon in about like 30, 40 minutes, we're going to have an AI 101 for research. So it's also going to be in this room if you would like to join. And we also have some other AI related workshops for you. I'll include this in the slides when I send them out as well. So please feel free to join then. But with that said, I would like to thank you all for your time. I think we have a few minutes for questions, but yeah, thank you all. Appreciate it.